Hello students, welcome back. So today let's try to understand the most simplest fundamental law with respect to electrical circuits, which is famously known as Ohm's law. Well, this particular law was actually stated or in fact experimentally observed by the scientist called George Simon Ohm. uh, he actually for the first time observed that there is a fundamental relationship between voltage, current, and the resistance which are associated with respect to any electrical circuit. He actually observed that when the resistance in a particular circuit is being kept constant, the voltage which is being applied and the current that is actually flowing through the circuit are directly proportional to each other. So we can rather say that the current that is flowing through an electrical circuit is directly and also linearly proportional to the voltage that is being applied. So let us try to understand it by considering a simple electrical circuit. So let us just assume that a voltage V is being applied, due to which a current I is flowing through a constant resistor, say R. So this is the positive terminal and this is the negative terminal, which means this end is at a higher potential when compared to the negative end. So due to the applied voltage V, a current I flows. Okay. As per the conventional current terminology, the direction, we say that the current flows from the positive terminal to the negative terminal. Or if we actually consider the direction of the electron flow, then it will be in the opposite direction, which means the electrons always flow from the negative terminal to the positive terminal. But we usually follow the conventional rule which says the current I flows from the positive terminal to the negative terminal. Now the point is, the current that flows through this particular circuit is directly proportional to the voltage that is being applied between these two terminals, provided the resistance R is being held constant. So how can we relate? We can relate it in this way. The current I is directly proportional to the voltage being applied between the two terminals, or rather we can also say that V is directly proportional to the current I. So if you want to put it in terms of a very simple equation, then we can write it as voltage V is equal to current I multiplied by the resistance R, where R stands as the proportionality constant. Okay, so we can always say that V is equal to IR, or the current I is equal to V upon R, or suppose if we want the resistance R, then it is always V upon I. Okay, so in this case we are considering that the resistance is constant. Now suppose if the voltage V is being increased, then what happens to the current I? Okay, because the resistance is being held constant, and we say that the current and the voltage are linearly proportional with respect to each other. So if the applied voltage increases, so does the current flowing through the circuit also. So it also increases. So if you want to put it in terms of just the notations, then if the applied voltage increases, then the current flowing through the circuit also increases. Now suppose if the applied voltage decreases, then the current flowing through the circuit also decreases. Okay, and this thing happens considering the R is a constant. Okay, now similarly, what if the voltage is being held constant and R keeps on changing? Okay, so which means let's consider the resistance R equal to V upon I. So if I consider the applied voltage to be constant, okay, then what will happen if, suppose if the resistance of this particular circuit keeps on increasing? Okay, so we can very clearly see that the resistance and the current I are inversely proportional with respect to each other. So if we increase the resistance, then automatically the current through the electrical circuit decreases, or rather, suppose if we decrease the resistance, then the current always increases. Okay, so that means the resistance and the current are inversely proportional with respect to each other. Okay, so these two things are the most important, the observations that we are supposed to understand with respect to Ohm's law. Okay, what is the unit for the resistance? Well, for the resistance, the unit is ohm. So let us just try to understand the units. So for the resistance, the unit is ohm. For voltage, we know that it is volts, and for the current I, it is amperes. Okay, so let us just try to consider a very simple example and try to understand the relationship of the three parameters, which are the voltage, current, and then the resistance. Well, as it was already told, the Ohm's law is voltage is equal to I into R. Okay, now let us just consider that the applied voltage be 1 volt. Okay, and let R be constant. Okay, just for an example, let it be again 1 ohm example. So what will be the current I? Okay, so well, the current I is equal to V upon R, which means 1 volt upon 1 ohm, which is as 1 amperes. Okay, so this is just an example. Now what will happen if I increase the applied voltage from 1 to 2 volts? Okay, so again, if I increase it from 1 to 2 volts, but keeping the resistance same, then it is 2 volts divided by 1 ohm, which is again 2 amperes. Similarly, if I further increase it by 5 volts, the applied voltage, keep the resistance as same, then I'll be getting 5 amperes. Okay, so if we just go through the trend and observe it, it is seen that as the voltage increases, so does the current flowing through the circuit. Okay, so similarly, if we reduce the applied voltage, then the current flowing through the circuit also decreases. Okay, so the one term which can be expressed here with respect to Ohm's law is that the voltage and the current are linearly proportional. Linearly proportional with respect to each other. So this is actually the relationship between the voltage and the current. Okay, so we have one more term which is called as the power. Okay, so usually the power is expressed in watts. Okay, well, the definition says that it is nothing but the energy consumed or the rate at which the energy is being consumed in a particular circuit. Okay, so it is energy consumed with respect to time. But with respect to electrical circuits, how can we relate it? Well, if I just consider a very simple circuit, as it was mentioned, wherein a voltage is being applied and a current I is being flowing through a resistance R. Well, we can say that what is the energy consumed? Well, the energy consumed is nothing but the work done by the electrons in moving from one terminal of the battery to the other terminal. So it is the rate at which the work is being carried out by the electrons between two different points, or no, or it's rather between two points which is being, or which is having a potential difference of 1 volt. 1 volt. Okay, so in that case, how can we define the power? Well, power is nothing but voltage multiplied by the current. So this is V into I. Well, V is nothing but IR multiplied by I. So we can say that it is I square R. So power is directly proportional to the square of the current that is flowing. So we can rather write it as P is directly proportional to the square of the current. Now suppose if you want to put it in terms of voltage, then we can also write it in this way. The power is equal to V into I, okay, where I is nothing but V to V upon R. So it is V square upon R. Okay, so we can also write the power in this fashion also. Okay, so overall that means the power consumed can be written as to be directly proportional with respect to I square, directly proportional with respect to V square, okay, provided the resistance is held constant. Thank you.